All right, so how do we solve an exponential equation? The way I want to show you today is that an exponential equation is any equation where the variable is in the exponent. So please copy this example down. 2 raised to the x power equals 8. In order to solve an exponential equation, we will take the exponent and bring it down. We will take the exponent and we must bring it down to the base level. So that's the first thing you need to know. In order to solve an exponential equation, the exponent must be brought down to a base level in order to solve for the exponent, in order to solve for the variable. So whenever we bring the exponent down to the base level, we have to write the word log. So I'll show you that one more time. We have our exponent. We must bring the exponent down to the base level. Once we bring the exponent down to the base level, we have to write the word log. So right now we have x times log of 2. Since we wrote the word log on the left side, and if you know about solving equations, if we wrote the word log on the left side, what do we have to do on the right side? Haley, you have to write the word log on the right side. So whenever you solve equations, whatever you do to one side, you have to do it to the other side because it's an equation. So it's log 2 log of 8. So this is x times log of 2 equals log of 8. Any questions about what's going on so far? All right. So since this is x times log of 2, how can we isolate x? How can we isolate x if this is x times log of 2? Nicole A. Divide both sides by log of 2. Since this is times, the inverse is division. So we'll divide both sides by log of 2. Divide this by log of 2. Just to give you a quick refresher, I don't see a base here, so what's the base? 10. 10. So it's log base 10 of 2. But since there's no base, we know that it's 10, right? In your calculators, log of 2 divided by log of 2. Anything divided by itself cancels out. So log of 2 over log of 2 cancels out. These are basic mathematical principles. The only thing left in the left side is x. X equals log of 8 over log of 2. Is everyone with me so far? Once we have x isolated, take out your calculator. And in your calculator, we're going to enter log of 8 divided by log of 2. The easiest way to do it is to hit alpha y equals to get our fraction. So hit alpha y equals, and now we have the fraction. We could just hit log. Log of 8 over log of 2. Does anyone need me to repeat those steps on the calculator? Log of 8 over log of 2, hit enter, and x equals 3. Example number 13. Please copy this down. Am I going too fast? All right. So if you remember from the first example we did, Our goal is if we're solving an equation and the variable is an exponent, we have to bring the exponent down, right? When I bring it down, what do I have to write? Log. Now, the only difference is we have two exponents here, so we have to bring both of them down. Both of them have to come down. And since both of them come down, we just write the word log just one time in front of each of the bases. So it's 3x log of 2 equals x plus 1 log of 4. So whenever you bring an exponent down to the base level, you have to write the word log right after the exponent. Any questions? And this is 3 times log of 2, x plus 1 times log of 4. I'll divide this by log of 2. If I divide this side by log of 2, I'll divide this side by log of 2. Log of 2 over log of 2 cancels out. The reason why, because anything divided by itself is 1, right? If you were to put log of 2 over log of 2 in your calculator would say 1. So this is essentially 3x times 1, which is just 3x. This is x plus 1 times log of 4 over log of 2. So we'll take this log of 4 over log of 2, and what do you think we're going to do with that? Plug that into your calculator and see what this value is. So this is x plus 1 times, so this is times here, whatever this quantity is. What is log of 4 over log of 2? 2. Before I continue, does everyone see what's going on here? How we took log of 4 over log of 2, simplified it, and it's just the number 2. And now we have a simple multi-step equation, no exponents. Everyone should be able to solve this equation. X plus 1 times 2 is the distributive property. It's just multiplication here. So it's 2x plus 2, 3x. Subtract 2x from both sides. X equals 2. X is equal to 2. And let's just do a quick check. This is our first time solving exponential equations, so it would be in our best interest to check our work to see if we did it correctly. X equals 2. Does anyone have any questions before I do the check on the board? X equals 2. So all I need to do is go back to the original equation and substitute all of my x's with 2's. So we have 2 raised to the 3 times 2 equals 4 raised to the 2 plus 1. Are these two equal to each other? We'll see. 3 times 2 is 6, so this is 2 raised to the 6th power. Does this equal 4? 2 plus 1 is 3. 4 raised to the 3rd power. Can someone please put 2 to the 6th power in their calculator and tell me what that is? 2 to the 6th power. Brianna? 64. Is 64 equal to 4 to the 3rd power? What is 4 to the 3rd power? It's also 64. So we did our work correctly because 64 equals 64. We know that x is equal to 2. Any questions on these two examples? We could really stop here. There's nothing new. I just want to show you a few more because not all of our answers are going to be integers. Example number 15, everything is exactly the same. I just want you to do this one because our answer is not always going to be a perfect integer. Sometimes it will be a decimal. And this is a case where our answer is going to be a decimal. So again, the first thing we want to do is take our exponent, bring it down to the base level. So we have x equals 3. And whenever I bring an exponent to the base level, I have to write the word log. So x log of 2 equals log of 3. Again, this is being multiplied by log of 2. So we'll divide both sides by log of 2. Log of 2. Log of 2 over log of 2 cancels out. The only thing left on the left side is x. X equals log of 3 divided by log of 2. Once x is isolated, we could throw this expression into our calculator. Log of 3 over log of 2. So in our calculator, we can hit alpha y equals. Now we have the fraction. In the numerator, we'll put log of 3. So log 3 over log 2. And hit enter. And we get a decimal. 1.58496. 1.58496. And we'll round this to the nearest 10,000th place, 4 decimals. So it's just 1.5850. Everything is exactly the same. The only difference is sometimes we'll get decimals, sometimes we'll get integers. That's the only difference. Now I want you to think about this one for a second. It's a little bit different. I want you to use your knowledge of equations when you solve an equation. Everyone knows how to solve an equation. What do you think the first thing we're going to do here is going to be? It's a little bit different than the first step we did on the previous ones. Danielle?
Minus 8 on both sides?
Absolutely. Subtract 8 from both sides, because if we want to isolate x, we have to isolate 10x first, right? Simple equation principles. And to isolate 10x, subtract 8 from both sides. 10 raised to the x power equals 1,000. Now, here, since 1,000 doesn't have an exponent other than 1, now, Danielle, we have options. We could use this one here if we want to, or we could do it the way we've been doing all the other ones. So let's just keep it the way we've been doing it. We'll bring the x down to the base level. Once I bring x down, I write the word log of 10 equals log of 1,000. Divide both sides by log of 10. And x is equal to 3. Log 1,000 over log 10 is 3. And here is the proof. Alpha y equals log 1,000 over log 10, and that is 3. 3 is our answer. Exponential equations. Does anyone have any questions? Last example. Do this one on your own. Take about a minute and a half, actually 2 minutes, and we'll compare answers in 2 minutes. Victor, what was the first step you did? So you brought this down? All right, so you brought the 3x minus 4 down, and what did you write? Log of 2, because the base is 10. All right? Log of 5. How about the next step? Not Victor, not Brianna, not Haley, not Danielle, not Nicole. Tessa.
You divide both sides by log of 3.
Divide both sides by log of 2. Again, our exponents aren't always going to be pretty integers. They may be decimals sometimes. If they are, just round to 4 decimal places. So now we got to figure out what is log of 5 over log of 2. 27 calculators. Yes, Francis. 2.32 anymore, or does it stop after the 2? All right. All right, I'll take the 1.9. That's cool. Thank you. 2.3219. Because if we're going to round, the more decimals we have, the more accurate our final answer is going to be. Huh? No, we'll leave it here because the number after the 9 was what, like 2, yeah. So we'll leave it there, yeah. Yeah. All right, now what do you think is next? Haley, add add 4. 3x equals 4, excuse me, 6.3219. And someone brand new, someone just put a smile on my face. Someone who I haven't heard from in a while. Yes, Madeline. Divide by 3. And what did you get? Did you already put that in? What is 6.3219 divided by 3? Danielle.
2.1073.
All right, perfect. Thank you. So that is what x is equal to approximately. So we'll just put these little squigglies because we've been rounding. So this is the approximate answer for x. That is the end of the lesson.